maybe I should talk a little bit about the system and introduce everyone. So I'm a PhD student from the Hasso-Plattner Institute, and I'm doing my PhD on tools and on tooling platform and exploratory programming. And one thing that I was interested in as part of my master's was multi-language programming platforms. And of course, GraalVM is a polyglot VM, one of the very few, and it's designed for doing polyglot. So I thought maybe I should move to GraalVM and build my environment, rebuild my environment there, and that's what TruffleSqueak basically is. So TruffleSqueak lets us use a Smalltalk programming system on top of GraalVM. And some of you might not be familiar with Smalltalk and what Squeak is. And so maybe just some background on that. So Squeak is an implementation of Smalltalk 80. It came out of that. And I think Squeak was built in 1996 or something like that. So it's an older system. Smalltalk 80 is from 1980, so even older than that. And Squeak is still using old infrastructure like BitBlit. So BitBlit is an extension in the VM that lets Smalltalk do drawing operations, and that was already at that time that was the best that they could do by like drawing different forms onto a canvas using different operations. So and all
exactly,
of this
yes, cool. I think I'm getting ready.
Part of Smalltalk. So you already have the doc.
Yes, I shared the doc.
The link.
I shared the link to the doc. Yes, if you want to try this at home, either later or while we enjoy it here live, follow the link. And there's quite a lot of setup steps. And I did some of them before, so we can go right into the TruffleSqueak.
Yes.
But yeah, let's check out. I mean, I have a GraalVM installation here, and I have a lot of fun stuff installed in this GraalVM installation. If you can see it on the screen here, we got installed, of course, GraalVM Core. We got Faster installed, LLVM, we got Python, Ruby, and we got TruffleSqueak installed, which is a third-party component. Yep. And you could get it from here. Okay, so Fabio, so how do I start this thing? I just
Yes, so once you have installed this with the GraalVM updater, which you have, there's a new binary or a symlink in your GraalVM's bin directory called TruffleSqueak. So you should be able to run.
Right, so I do TruffleSqueak.
Bin TruffleSqueak, or if that's in your path, I think there's an E.
Oh, yes, I missed it.
Yeah,
that's good.
Yeah. So now it's loading a real Smalltalk image file into your process, on top of GraalVM. So every Smalltalk object is now represented by a Java object. I think you can just maximize the window.
Yes.
And so that's what the programming environment looks like. This is the TruffleSqueak image as it comes with an open workspace, and the workspace is like an interactive REPL where you can evaluate expressions.
Right. So Smalltalk was one of the first programming languages to be that interactive, right? To have like this concept of programming. So what can I type here in terms of Smalltalk expression? Help me out.
Yeah, well, of course, we can start with something really simple, like 1 + 2 × 3 or something.
1
like
+ 2 × 3,
yeah.
right? And then I need to press something special to evaluate it, right?
Yeah, if you right-click, you get a menu.
Right.
And the menu tells you there's like, I think in the fourth part of this thing, it says do it, debug it, print it, inspect it, explore it, and button for it, and things like that. So you can print it. And if you run print it, it will print the 9.
Right.
So if the cursor has a selection, it will evaluate the selection and print the result. If there's
I can also just evaluate those to 6.
Yes.
Right?
Yeah. So if you do that, and as a printer, you get
6.
the 6.
Okay. Good.
Yeah. And of course, there's shortcuts for this. So Command P on Mac, and I think it's Control P on Ubuntu on your machine.
Right. And I can also evaluate something that will give me maybe something more funny, like this. They have this Graal status somewhere, right?
Yeah. So this whole programming environment, including all the graphics that we see, most of this is implemented in Smalltalk itself. So I'm always interested in knowing what the Graal compiler is up to. And for that, of course, we build a little tool. So what you can do is if you press enter and go into a new line, I think you can write something like Graal info morph. So a morph is a UI component in Smalltalk, and we send a message to it with a space, and then we say new.
New, okay.
And we send another message to that instance, and that would be open in hand, and that would open the morph in your hand. And now you press Control D.
Control D.
To run this line, and you end up with.
I end up with something on my cursor, right?
Yes. So you can drop this in the menu bar, like next to where the help is. That's what it's designed for.
I'll carefully drop it on that menu bar.
Yeah,
cool.
Don't click on it again.
Right.
Just yet. Maybe you have.
Okay, no, I don't think I have.
No, you haven't. No, you haven't.
So this shows, what does it show here?
Yeah, so this morph does VM introspection. So it looks at the Graal runtime object, and from there it can find the Graal compilation queue, and it basically just shows us how much is currently in the compilation queue. So at the moment we're at 400, and you're not doing anything with the Smalltalk environment. So that means the Graal compiler is currently compiling methods, and it still has about 400 to go, and the number is going down. So as you interact with the environment, we'll see more methods being compiled because, like I said, everything, including the drawing and including interop, is all implemented in Smalltalk itself.
Right. So even if I move the cursor.
Even if you just move the cursor or just open the menu, open the tools menu.
Okay.
We should see like a bump in the compilation queue.
Yes.
So now it's at now it's at almost 400.
Yes.
So more code becomes visible, more Smalltalk code becomes visible, and that means the compiler decides there's more hot methods that I like to compile, and it adds it to the queue. So as we keep working with the environment, we'll see the number going up. And in my environment that I have running on my machine right now, it's been running for like a couple of hours. The number is down to 0. And of course, if I start something new, it will see more code, and the compiler will be busy again.
Right. Right, cool. Okay, so what are we gonna run here next?
Yes, let's do something simple. So let's start interacting with the polyglot API.
Okay.
So in other GraalVM languages, there's like a module or something like that. We don't have a module system here in Squeak, but we do everything with polyglot via the polyglot class. So if you go to the next line and type in polyglot with a capital P, that's the polyglot class.
Right.
And we can send a message evaluate : and then eval
colon.
Yep, colon, and then Python,
okay.
Yep, and then string, and then we do the same expression from before.
Right.
So you've noticed that in the first time we ran the Smalltalk code on the top, we got 9 because that is Smalltalk semantics. If you do a print it now,
Control P, right?
Environment. So what's happening right now is it's loading Python into your object memory.
We see the Graal queue is spiking.
Yes. So it's spiking because the Graal compiler is now warming up the Python standard library, I guess, and some other things, the polyglot API.
Right. All right, cool. But we are now running Python here, right? So I can do some Python expressions. Like, and I can basically delete this, right? I can say,
remove the 7 because that would still be part of this. So you can evaluate an empty list.
I see. Yes. Okay, that's like this.
If you do Command P.
Yes. Oh, okay.
We will see this is a foreign object. It has no corresponding object in the Smalltalk world. It has members and it has an identity. And members could be either fields or methods, and depending on the language. So this is exposing in the interop protocol directly, and this printed string is basically language agnostic, so it works across all languages. So instead of doing Command P, can you do Command I?
Command
So remove
I.
that.
I remove that again, right? Because otherwise it becomes part of that. Yes. Command I. Yes.
Yes. So this opens a second Smalltalk tool.
Okay.
This is the inspector, and it opened it on this new list. And if you click on self, we would see the same string. But if you click on meta object, we'll see that's actually the meta object. It's attached to this list. But if you click on meta object info, we get some more information. So this just says it's a list, and its qualified name, it's also list, but it's a lowercase list because the meta object is the list class in Python. So this works for all Truffle languages. If you click on language info, we would see
it will tell us. Oh, it will tell us this is a Python object. I see. Okay, cool.
Yes, it's a Python object, and there's a source attached. So for some reason, this object even knows how it was created. That's the expression that you ran. If you click on readable, we would see the Python fields that it exposes. For some reason, built-in methods are exposed in there as well. And invocable members are basically functions, or bound methods in this case. So the Python interface is quite large, but the public interface on the bottom is not that big.
Right. Which is, because this is private, right? Private is __.
It's considered private. You can still send it, but it's considered private.
Okay.
So we can see that this list exposes append, and we know, and if you have used Python list before, you know with append, you can add another item if you put that item in as an argument. So on the bottom of this tool, there's another workspace. And in here, we would use Smalltalk syntax, but we can send a Python message. So you can type in self and then append.
Self.append or just self?
Space append colon.
Right, because that's what it is. Okay.
Yeah, and then do 42, for instance.
Right.
And then Command D.
Command D, right? Yes. Okay, cool.
And so what you notice is there's now a 1 because that's what the inspector does for lists. So this is now an interop list, an interop array, and at position 1, Smalltalk is 1 indexed, and there's now the 42. So let's append another object. Let's append a complex object. Let's use the, how about the Smalltalk object?
Okay, so
So if you type in Smalltalk, that's the global Smalltalk object, basically. So if you do another...
Control D, yes, okay.
Yes, Control D. So that's also now on the list.
Oh, that's now a Smalltalk object. Okay.
Yes. So this is not very surprising, but if you click on Explore on the bottom, you will change the view of this inspector into this view, into a tree view. And in here we can see that we have a list, a Python list, because it has the Python icon. The 42 doesn't really have a language because it happens to be represented by a Java long, a primitive, and it doesn't belong to any language. But the Smalltalk object belongs to Smalltalk, obviously. So that's why we see the balloon. If you open this, you would see.
I can explore the members of this.
Yes, you could. I'm not sure why it's showing nil on the right. I should write that up. But that is. Those are the methods of the object, but apparently they can't be read at the moment. Yeah, that's something I'm currently working on. So as some of you might have noticed, we are running a dev version here. So this is using
this is the latest and greatest of TruffleSqueak.
Yeah, it's using a new interop implementation.
Okay, cool.
Okay.
Yes, let's see that interop implementation in more action, right? With we can do also notebooks that are polyglot, right?
Oh yeah, of course. So imagine you get the inspector out of the way and open maybe another workspace. There's a button on the top left. No, click on workspace one more time.
Just one more workspace. Okay.
Yeah, and move that underneath the other workspace.
Okay.
And if you go to the top right of this window, there's this blue button.
Yes.
And this lets you change the base language of this workspace. So let's go to Python or Ruby. Yeah, doesn't really matter.
Python is
That's fine. Ruby will work too.
Okay.
Just do 1 + 2 × 3, for instance, and use the same shortcut for printed. And now we get a 7. Yeah, Command P. And that means we can basically, when we change the base language, we can now from now on evaluate Ruby code. So now you would be able to require stuff and interact with the Ruby standard library, load Ruby modules, and so on. But we already have now 2 workspaces, and the last thing that is missing is a way of exchanging data between the languages, because then if we put a 3rd and 4th underneath the workspace, you don't have to do it now, but we essentially end up with like something like a notebook, like a Jupyter notebook. But the really cool thing is, for every cell we can change the
language for every cell, right? Because we can open another workspace and say this guy is going to be Python.
Yes.
Right.
So get all these workspaces out of the way.
Okay. Let's get rid of them again. But these are funny functions, right? What can I do on these windows? I think I need to control something, or how do I?
What do you mean?
These windows have a lot of functionality. How do I do this again?
If you press Alt.
Yes.
Don't use the X right now, but these are called halos. So if you use the button, the button on the bottom left, the blue one, you can twist the workspace.
Rotate.
Oh, maybe you didn't click it right.
Okay.
Yeah. Oh, for some reason this is not working. Interesting.
Let's go to the left here.
That's an amazing piece of functionality that I always wanted to have.
Oh, now
rotate my window.
Yeah, and you can still interact with it and type in your code.
Oh, that is insane.
Yeah.
You know when it was be good? When you're laying on a couch with your laptop and you're too lazy to actually move.
Right.
Twist your workspace a little bit so it still kind of matches your orientation.
Yes. I could show you how to do that, but you can even like have them rotate all the time, and then you have to move your head.
All right. I think that brings polyglot programming to a completely new level.
Yeah. Well, the Graal compilation queue is at 2,000 at the moment.
Oh yes, we are stressing it a little bit.
Yeah, so if you click on this guy, maybe click on it, this will take a while. So the time is now frozen in the image, which tells us it's busy, because this guy is loading R now, and it's using ggplot to render the queue size over time.
Right.
So let's wait for it a couple of more seconds.
Okay.
But here we go.
We have it. Yes.
Here we go. And
okay, I see.
This thing I really like, because it's rendering using ggplot, but it's rendering directly into a Smalltalk bitmap.
Right.
Yeah, I'm not sure you can twist it and it will stay live, but yeah, you can rotate it, it still works.
Yeah, it is rotating. It did work.
It is still updating.
Of course, it's still updating. Yes, it is.
Yep. And yeah, we can see that at some point you decided to load another language. That's where we had a jump for Python. And then we loaded a couple of more languages, and only recently you loaded R and ggplot. So that's why the compilation queue is quite high.
Right, it's at 2,500. It should be okay, right?
Let's see. There's a comment right there. Oh yeah, right.
Yeah, so this is insane. And this technology, how old is this Smalltalk implementation?
Well, this implementation is more than 20 years old.
Right.
And but the image that we see right here is, I think, based on a trunk image from yesterday. So it's still being maintained by a bunch of people. And TruffleSqueak makes use of the latest and greatest Squeak release, or Squeak trunk image. So, but we wanted to do a notebook, right?
Yes, we wanted to do a notebook. So I guess I need to now close some windows here.
Yeah. Let's get these out of the way again.
Let's get the windows out of the way. Okay.
And let me put a link into the chat. So if you could open that on your screen, that would be fantastic.
Okay. Yes, I will open it. Oh, where did you put it? In which chat? You put it in the...
Yeah, here you go.
Yes, exactly. Good. Oh, this is our demo. Yes, that's right.
Yes. So we need to do an example, of course, for a notebook. And as an example here is a website, a conference website that shows us the contributors for a conference called Programming, which is happening in about 2 weeks. And let's say what we are interested in is how many contributions per country this conference receives. And what would we need to do? First, we would need to download this website. We would need to extract the table, but this is not a simple HTML table. If you look at the source, you don't have to, but this is not a normal table. We need to do some data cleansing, and we want to visualize all of this, right?
Right.
Okay, so let's do this in a polyglot notebook. So it's time to click on the
notebook. Exactly. Okay.
Yes.
Initializing polyglot environment.
It is loading Ruby and the Ruby library because it's using that for syntax highlighting.
Right, and we have an example file that we're loading now, right?
Yes. The example file is linked in the document in the GitHub gist. Yeah. So essentially, what you can do if you click on Add Cell, maybe on the top right, further on the right, next to Run All, or next to the Load button.
Yes. Okay.
Yes. Yeah. There's by default it's a Markdown cell. So if you type in some text into the cell, just click in it and type in some text. You get Markdown, some slight Markdown syntax highlighting. And if you click on Markdown, you can change the language of the cell. So if you use, for instance, Python or Ruby, doesn't really matter. Just pick one. And if you run this cell now, it would evaluate that piece of code.
Right. Can I run just this cell somehow?
Yes. Just click on it and say run, and then you end up with this is just an empty list.
And the Markdown would be a document of some sorts.
A Markdown is just to keep notes in this document.
But if I would run it, will it like...
No, it won't do anything. So a Markdown is just a text cell in a notebook. So these are used for documentation purposes. So in a normal document, in a normal notebook, you would start with like an intro, and then you would say, okay, we want to do this, we want to analyze this. And then you add another code cell. This is some form of live literate programming. But let's remove that last cell again. So just click on the cell. Let's remove that last cell again. On Markdown.
Right. Yes, Oleg, if you're here, we need some moderation in the chat, I think.
Oh, I'm on it.
I mean, I certainly want to become famous, but that's okay.
Interesting.
All right.
Yeah. So just click on Markdown again and remove the cell. Yeah. Just click on it and say remove. Yep. Now the cell is gone. So if you could evaluate the first Ruby cell, that would be great. What this does, it's downloading the website that we just saw using Yuri Open, which is really nifty in Ruby.
Okay.
And it's putting that into Nokogiri, which is a powerful HTML parsing library. And that is basically just like JSoup. And in the following 2 lines, that's all we have to do to extract the data using that parsing library. So what we are interested in is PERS affiliation and PERS country in this results table. And we store the result in this magic bindings object.
Okay, cool.
Yes. And we call the result rows. And what you can see on the right is an explorer on this bindings object. It contains itself as a that's a technical reason. So other languages can have access to this object too. But this really is just this polyglot bindings object provided for Truffle language implementers. So this object, all language implementers have access to, and that way they can provide polyglot export and polyglot import. That's exactly what this object stores. So under rows, we just stored a new object, and if you could click on rows on the
rows,
right,
where? Here.
Yes, if you can click on that,
right,
you would see this is a Ruby object with lots of inner Ruby objects, and if you click on one of them, we would see
one, yes.
Yeah, we would see they contain strings again. Yeah, now you're
this
looking
is the
at the
invocable, what I can invoke on this object.
Yes, those are invocable members of this object. So this is the interface of this Ruby object. So
this is just foreign string Harvard University, foreign string United States.
Yes.
Okay, cool.
Yes. So that's the data from the website. So we have an array of Ruby strings. Okay.
Cool.
So in the and it's 192. I think on the website it said 192 as well. So we managed to download all of this in Ruby. So in the next code cell, if you run that,
which is the Python one here, right? Because the Python is now accessing these rows.
Yes, exactly, and it's using this PyCountry library,
right? Which allows us to sanitize the data here. Right?
Exactly. So run the cell.
Run the cell. Okay.
And it's basically just checking is a country name in the second element of the list. And as a result, we end up with a new list. And this list contains 170 entries. So we can be a bit smarter than just checking the affiliation, but also checking the country, not just the country, but also the affiliation column. So if you could, we could extend the code. So that says if CNAME in row 1, we can add an OR statement, or CNAME in row 0.
Right, what does it do here? It means, okay, if one of those is the country.
Yes, if one of those contains the country name. So rerun the cell.
Right.
And we get 124.
124
okay.
Now, okay.
Yeah, that's the best we can do for now. Okay, and now on the right, maybe collapse the rows and expand the countries object. And the countries object is a Python object, a Python list. If you look at the invocable members, it only has 42
this is marked as a Python object here, and it's referencing Smalltalk strings.
Yes, it looks like it. That is not the case. So the reason here is we can make Python strings appear as Smalltalk strings transparently to the user because Python strings are immutable, while Ruby strings are not. So it's okay if we show them here as Smalltalk strings and provide the full Smalltalk string API. Yeah.
Cool. And now we can plot it, right?
Yes. So if you run the R cell,
which is down here. Here's the R cell, which is using ggplot.
It's again using ggplot, and this magic, the %ggplot2 instructs the notebook system to add some glue code around it. And what we are doing is we put the Python countries list into a data frame, an R data frame. We use the aggregate built-in. And then we print the result using the ggplot API, and that is now the plot. And
excellent.
There was, that is the visualization. So the United Kingdom is on the top, I believe.
Yes,
and Germany is second.
United States, Belgium, Netherlands.
Yeah,
etc.
Right, and the line is the mean because that's the last line in the code cell. It says geomean. H line, and we want a mean on contributors. Yeah,
cool.
So other conferences are using that as well. For instance, ECUB, the European Conference for Object-Oriented Programming. And if you put in
same different conference but same website, kind of.
Yeah, same content management system, right? So if you
I can on the top here move to different conference.
Yes.
before I run it.
Yes. Before you run it, you might want to preserve your graph. So we're still in a live environment, so you can actually get this object out of there by right-clicking and by cloning the form.
Form, okay.
Yeah. So now you have a copy of that object, which is independent data-wise.
I guess I can also rotate it.
Yes, you can. Of course you can.
Cool. Perfect. Okay.
Yeah. Put this to the side.
Let's put it to the side. Okay.
And click the Run All button, which you can
Run All button.
still see.
Yes, here.
Run.
Right?
Yes. So now we can see how data flows from the top to the bottom. This conference has a couple of more people.
Yes.
Yeah.
Oh,
and
yes.
that's it.
Oh, and that one seems to be dominated by Germany. So ECOB is dominated by Germany. Is that what's the result of our analysis here?
Yeah, ECOB 2020 was apparently dominated by Germany.
All right, cool. All right, and we can now extract this as well, right? Clone form.
Yeah, of course, if you want, or you can even export an SVG if you want, and send this to your colleagues for information. But yeah, that's
cool.
That's a polyglot notebook on top of GraalVM using 4 languages.
And in this case, using R for plotting, and I can move one plot next to the other. One is now a little bit skewed because of my prior actions, and I can compare them.
Yes, you can compare them.
So it's kind of a more advanced version of Jupyter, right? It's kind of like, because you can also clone these things.
Yeah, of course. So Rotten Roll has to leave, but he enjoyed the polyglot notebooks even more than the twisted windows.
Thank you, Rotten Roll.
This is actually an interesting question, since you mentioned the Jupyter, right? Is there or could there be, technically, like a web application environment that kind of sort of supports this, right? At least in a normal Jupyter setting, or do you require something more sophisticated than that?
So a Jupyter kernel, which is basically the name for a Jupyter server, could be implemented fairly easy. In fact, we had a couple of students working on that. Let me post a link. So this is called iPolyglot. The original Jupyter kernel came out of IPython. So iPolyglot is a play on that. And this is a Jupyter kernel that allows you to run the same notebook that you just looked at on top of GraalVM through a normal Jupyter environment. But the thing is, though, we were able to build the notebook system that we just played around with on top of GraalVM while it was running. And it's much easier to experiment with this environment that you just saw. So the lessons that we've learned in this environment, we can transfer them to other programming systems like the real Jupyter environment. We even have some students working on a VS Code integration. So VS Code has this new notebook integration, and we are working on supporting that with a similar programming experience that you just saw, but outside of Smalltalk.
Cool. Very cool stuff here. Okay, so I need to close some windows, I guess.
Yeah, you can.
So I need to Alt.
Yeah, Alt click and then press the X button.
Right. Okay.
And we can
Thomas,
close that.
I have a question to you, actually.
Yes.
Right.
Okay.
The Graal queue there is it's kind of high, right?
Yes, it is.
Is the compiler actually doing something? And
yes,
do you think this is reasonable?
We were wondering the same thing, and the answer is yes, it is doing something. So we can.
I thought it's supposed to be like a fast runtime, no?
Yeah, of course, it is fast. Here we see the CPU time consumed is 450%, but it is running a huge amount of code.
And it constantly sees new things as we clone an object or run a notebook and load another language and load another library.
Right.
In fact, we can this morph can do introspection. When we can do even more, if you look at the gist, there we can interact with the Graal runtime and see what the compiler is currently up to.
Right.
So. Yeah,
yes,
close the notebook.
Close this one. Yes, but also to answer your question more, Oleg, I think we should be able to optimize this. I think this could be a very good use case for optimizing our compile queue, because it seems. I mean, yeah, I don't know how much code is behind it, but it's certainly worth to investigate why it would always stay pretty high.
Yeah,
but I think there is some loop probably, right? There is some constant updating of the screen, even if it don't do anything, I would assume.
If you don't do anything, the number will go down.
But I think there should be still like the frame rate that draws everything from scratch is still happening, right?
Yeah, but at some point that will stabilize.
Right.
So the assumption that your application stabilizes is only given if you don't do anything in this environment and don't run something that produces new code.
Right.
Yeah.
Yeah. But, I mean, we should check out why this is going that way.
Yeah, of course. So
cool.
I wanted to say that we can actually look into the queue.
Okay.
So
yeah.
we can see what's going on.
I guess I need a workspace for this. Right?
Yes, you need another workspace.
Okay.
And the code for that is in this GitHub gist.
Right.
Graal runtime, that's a bit more than we've seen before. Starts with Graal runtime and then get compile queue. So this is doing interop. So yeah, doing inspected. Doing inspected, because otherwise we won't see anything.
Right.
Yeah, so this gets the Graal runtime object, and from there it takes the compile queue and it extracts the compile tasks. So if you click on like one, we see it was compiling point minus a Smalltalk method, and that was a splitted method.
Right.
So if you click on something else. You see, this is
ages alpha, yes.
Okay. Yeah, these are all Smalltalk methods.
This is the current compiled queue, right?
At the time when you did the inspected.
Right.
Yes. So these are all Smalltalk methods. There's another point minus. Interesting. Unfortunately, you haven't. Oh, there was one. Go back. Go back. Yeah, yes. That is an R method, I believe. This is not a Smalltalk method.
Not null, yes. Num not null sounds like an R method.
Yeah. So in here are indeed other methods as well from other languages that are currently being compiled.
That are currently in the compile queue, right, to be precise.
Yes, they are in the compile queue waiting to be compiled.
Right. But it's interesting. Will it still compile it later on? Because, I mean, we should probably check if the method is still hot.
Yes, it's a very good point.
Because this could be a very good test case for a scenario in which we see some methods are hot, we put them into compile queue, and then later we figure out that by the time we get to compile it, the method is no longer hot.
Yes. So if you were to decide to never use a polyglot notebook anymore in this instance of TruffleSqueak, it would make sense to just reject all methods related to the notebook, for instance.
Right.
Yeah, but we can also build a tool with this, do even more things with the compiler.
Right.
So let me show you the call target browser.
Okay.
So what you do is you go into your workspace and you type in call target browser open.
Okay, so
just close this window.
Close this one, right? And here I say yes, okay. Open.
A system browser is the
do it or inspect it?
Just do it. We are not interested in the result.
Okay.
Yes. So this is a system browser, which is the tool that you would use to write Smalltalk code. So on the top left, those are packages. So if you click on kernel objects, for instance.
Kernel objects, yes, okay.
Yes. This is the proto object chain that you can see here. So this is the object class. Yeah, you can click on it. And what you can see in the third column is the protocol. It's not important. It's like a category. And on the right are the methods. So the hottest method is interop is member invocable. So this call target browser is a system browser on steroids because it sorts the methods on the right. Normally they are sorted alphabetically, but it sorts it by hotness.
All right.
And how does it do that? So it looks at the call target, and we can look at the call target in here as well. So if you click on source in the middle,
this
on the right, yes, and then click on call target.
Oh,
yeah, no documentation for this one. We can look at information stored in the call target. So this method was called 67,000 times until the compiler decided to stop looking at it and compiling it. And the first argument is there's no profile for it, but the second argument, it was always a native object, and native objects are strings or symbols in Smalltalk. So that's what the compiler observed. The return type was always a Boolean. So that's something that the compiler has observed. And within this method, when the compiler compiled it, it inlined member to selector for. So we can see all of this in this call target. And this has been collected for every method that runs or has run so far, right?
I see. Cool. Yes,
and you can if you right click on this, just right click on the list, on the red list, If you right click, we can also sort by non-trivial nodes, for instance.
Sort by non-trivial node count.
Yes. So now the list is sorted by which method is the most expensive one from the truffle perspective.
I see. And now the color indicates that.
Yeah, now the color indicates that. So this is not anymore the hottest method, but the method that is the most complex for truffle. So if you click on deep copy, for instance, it has a non-trivial node count of 142.
Right? Oh, cool.
Yeah, and it has a couple of other methods inlined, which is probably the reason why it is getting more expensive.
Right. Cool. Is the Truffle team like aware of these functionalities? Like.
Well, this only works for Smalltalk at the moment, right? Because
of course. But I think it could be like a good environment to, for example, tune the inlining algorithm.
Yeah, and well, it is really cool for two things. One is for the compiler engineer to tune inlining and things like that, and the other one is for users to find out which parts of their applications are hot and where to focus. This is a different kind of profiling, if you will.
Right.
Yeah, we can do an example. You want to play some Tetris?
Absolutely. Let's do that.
Yeah, so if you click on kernel objects again, just so we have the focus there.
Kernel objects, yes.
Yeah, and now you press Command F, I think,
Command
on your
F.
machine.
Yes.
Yes, now you can type in Tetris.
Okay.
Yep. Press Enter. Yep.
Okay.
So this is a Tetris implementation. If you scroll down a bit, we'll see that there are more classes in there as well underneath of Tetris. Yeah. So there's Tetris block and Tetris board.
Right.
Yeah. So everything on the right is gray though. So just click on initialize, for instance, the method on the right. Yes. So there's no call target for it because this method has never been invoked, and the compiler never had a reason to profile the method or create a call target for it.
Right.
So what do we do now? We start the game, right?
Right.
So you open a workspace.
Okay.
And you type in Tetris new. Open in hand.
Tetris.new, right?
No dot, space.
Space. Okay,
Yeah,
that's the Java programmer in me.
Yeah, no, fine.
Puts
and
it
then
there as
space open in hand.
Open in hand, like this.
Yes, and you do it.
Control D. Yes. Okay.
Yes.
Oh,
so now
that gives me.
Yes. Now you drop this on the right.
Right.
Yeah. And you can close the workspace. We don't need that anymore.
Yes, okay, I'm closing the workspace.
Yeah, so there are some controls. This is a really simple implementation. So with the arrows, you can move this thing to the left. With the pipe, I think it will stay straight. I don't know. You can play the game.
Yes, I can just move it left, right. Good.
Yes. But what we also just noticed is there's a call count of 1, and now there is a call target, and it turns out initialize is the most expensive one already. Let's sort by hotness again. So sort by call and loop count.
Here.
Yeah. Right click sort.
Sort by call and
the
loop
default.
count.
Yes.
Okay, cool.
So we can see that 7 methods were used, and row for buttons was called the most.
One, yes.
Yeah, only called 12 times, so not that much. Not that interesting. But you can go to Tetris board.
Right.
And
Tetris
that
board.
is
Yes, okay.
yeah, that's a subclass. And if you click on cell size, is that cell size? Yeah, the first method.
Yes. Okay.
This is called 1,000 times, and the number is changing, so we can see that the method is still being profiled.
Oh, I made a mistake.
It hasn't been compiled. It's still being profiled.
Oh, I see.
Yeah, and now go to move left, for instance. Go to move left.
Yes.
The method move left.
It's here. Yes. Okay.
Yeah, and it has been clicked, or you've used that 11 times. If you click on move left,
right now it's 12. Yes. Okay, I see 12, 13. Yeah. Yes. Okay.
So if you click on move right, we'll eventually see move right coming up the list.
Right.
That's the method. That's rotate anti-clockwise.
Yes,
you can
I always I'm by. Now I see what actions I'm doing the most here.
Yes.
Oh, I want to get at least one Tetris. Come on.
Right. While Thomas is playing, I have a kind of actually a question which I just came up with. Right. So Christian there in chat says that we have the compilation logs for Truffle, right? But not always have the UI like this. And this is it's a Java application, right? Like the UI is a Java application.
Yes, the UI is a Java application. So the outer window is drawn by AWT, but if you look at the code, it's the simplest code that you can imagine, because it's literally just drawing an int array, and the int array is completely managed by Squeak.
Yeah,
right,
and
so
you can make
very
this.
Easy. It should be very easy to create a web interface with that, right? Because you just draw on a browser canvas.
Yeah, you could do that. There are ways to run Smalltalk without a display, and then there are server frameworks, and you can even write a URL checker in Smalltalk if you wanted. And run that.
What I mean, like, can you imagine like this thing, this UI, if you can run it on the server, right? And then just you go on the URL, and it opens a window, and that window has that, but this is the browser. So on the client, you don't need to install those things.
Yes.
Right?
Yes.
I think that would be a very.
How do I copy this? How do I copy this window?
How do you copy this window?
Make a screenshot.
I wanna copy it.
Can I clone it?
Can I clone it?
Yeah, you can clone it. There's a clone button.
Where?
Do that again. I forgot which one it was. I think it's the top right, but I might be wrong. Top right button.
This one looks about
it. Yeah. Duplicate it. Yeah, there you go.
All right. Okay. So I see.
Okay, you're getting into another speed run.
Yes, I think. Okay, I see. Excellent. Oops! I think I destroyed it again.
You closed one of them, or you lost. I don't know.
Yes, exactly.
Yeah. So
I see, but I can clone it. I can play it upside down, and I can. This is really cool functionality. Yes. right.
Grasheim says your Tetris skills are lacking here a bit.
All right. Yes, I'm trying, but it's hard to play it simultaneously on 4 boards.
Especially when they're upside down.
Yes, and it is a big stress test for the GraalVM, by the way, Grasshopper. So
Yes,
if you want
yeah.
to next time optimize the GraalVM, you can play some Tetris here. All right, I guess I'm losing now.
You're about to lose the games.
Yes, I'm losing a couple games, but I see.
This context.
But
there
going
should be an
back
upside down
to
Tetris competition.
going back to what Oleg was saying on like rendering this for the web and stuff, like this could be interesting, right? If you can...
Yeah. There are other projects that allow you to open an image within your browser, and that's called Squeak.js. But there's also TruffleSqueak is also a great test bed for not just for polyglot applications like this, but also for like polyglot hybrid applications that are much bigger. So we have one student working on a new graphical backend for Squeak that is written and baked by AWT in Swing. So instead of like having these morphs and all of this drawn through BitBlit and onto this display buffer, we can turn Smalltalk into like a real hybrid. So the applications are still built in Smalltalk, but all of the drawing will happen in Swing, and that is, I think, really, really cool. And hopefully we can show this off soon. That would be great. He can already draw like the world, and there's a couple of other things that he can do, but it will be like crystal clear and all native resolution thanks to Java Swing.
Right.
I think it's really cool to see that.
Right, so we can now somehow see how many blocks I made. How many Tetris blocks did I make? No.
If you look at initialize, I think, yep. But keep in mind, this is the perspective from the compiler. So the compiler might have decided to never call that or to not call that method because it was inlined.
Right. Okay.
So the compiler might, or what you see here, might not be the truth. Because it's the view from the compiler. It's the
view of the compiler. All right. Yeah. I hope the view of the compiler typically is the truth, at least when it comes to the program. But when it comes to the profile, yes. I agree. It doesn't have to be the truth.
Yeah. So profiling is still a bit different, but right. But yeah, let's do something with the system window. So maybe close the Tetris game.
Yeah, just one more question for you, Fab, before we close this.
Yes.
It's like, can I somehow get this call count also for R methods or Python methods or something like this?
If you could get me a handle on a call target, you would be able to do that. Sure. Right. So I don't think we have built this yet, but all you need is a call target and a way to like enumerate methods, and then you could have a call target browser for Python and for other languages as well. Sure.
Cool. All right, excellent. Yes. Okay, now let's get out of here.
I can't hear you anymore.
Okay. Should be still okay, I think.
I can hear you, Thomas, and
right.
I can hear you, Fabio.
Hang on, maybe it's me.
Yes, I think it should be you.
I think your AirPods just died. Like the battery.
Yeah, connect your AirPods.
Okay, can you say something?
Yes.
Yes,
now I can hear you again.
All right, perfect. Cool. All right, I will close this window here. Okay, I'm back to my workspace, but the GraalVM is at 7,600. All right.
Yes. Hang on, my computer is a bit stressed.
All right. Yeah, it cannot be worse than my computer here, but...
Okay, so much better now.
All right, cool.
Okay, good. So if you look into the gist,
yes.
There's another thing that we can play around with. So let's evaluate Java type Java AWT frame, because that's what Oleg was asking about.
Right. Okay. So we now bring Java into the mix in our Smalltalk environment.
Yes.
Okay. So copy this.
Just inspect it.
Inspect it, all right.
Yes. So this does interop with the host Java. So this is not Espresso. This is the Java that powers all of this. And we can see this is still the same tool and it still behaves the same. If you click on language info, we should see this is Java host. This is the host language.
Yes. Version is 11. Yes, it's Java 11. Yeah.
If you click on readable members,
okay,
we see fields and static fields and some constants. If you click on invocables,
yes.
We see that this supports get frames. So type in self space get frames and send that message.
Self
get frames. And can you inspect the result? Do an inspected? No, yeah.
Do a Control I, is that right?
Control I, yes. Yes, so this is now the result of that call, which is a Java AWT frame array with one element, which we can see under one.
All right.
So
which is a host object.
It's another host object. So on the bottom you can say self at one. So at colon one. It's just AT, not the at symbol.
Okay, this.
Yes, that's the method. And do another inspect.
Okay. Oh, inspected, yes, okay.
Yeah, and now we have a Java frame object. And if you look at the members, it shows us its full interface. So if you've ever worked with an AWT frame, this should be familiar.
Right, yes.
So somewhere in there is like set title.
Right, and we can now actually, we can like set title, yes, that's right.
Yeah, do self set title and then put in a Smalltalk string.
And now...
And you can choose what you want.
All right.
Yeah, do it.
Control D.
Yeah, and now you change...
now our hello world is here.
Yeah, you could call set invisible, but don't do it.
Yeah, set invisible would be unfortunate.
You will lock yourself out. Yeah.
Right, but we can also make can we make an image out of our current state? Can we showcase this maybe?
What do you mean?
Can I save my current windows that I have here? Let's do something more interesting as well, you know. Let's say I'm really fond. Oh, how can I move this again? I know. Oh yeah, here I need to move it here. I really want to like save this awesome composition of windows.
Yes, so that's a very interesting question. Usually the answer would be yes, of course, because it's a Smalltalk environment, and when you save it, you'll snapshot all of this and save it to disk,
right? And
that's fine. In this case, though, we'll have a problem because there are now Java objects and Python objects and Ruby objects potentially in your heap. And that is not supported by the Smalltalk image format.
I see.
So what happens is, if you press save now and save the image and reopen, all of these objects will disappear and they will be nulled out or nulled out.
So save project here, right?
No, not save project. I'm not even sure what that would do.
Oh, okay. Okay.
Apparently it crashes.
Did you just crash it?
Yes.
Okay. Okay.
To be honest, the compilation queue was over 9,000. So
yeah, it was over 9,000.
No. But here we got a really cool
stack trace.
Stack trace. That's a really long.
Can you go up to the top?
Yeah.
And okay, so cool. This was a crash in BitBlit.
It was a polyglot exception. All right.
Yeah, it's a class cast exception because I was trying to cast a pointers object to a variable pointers object. If you could send me that, I'll try and fix it.
I will later send it. Okay, cool. Well, we can just start it again, and this time we can. Our queue is cleared out, right? And now I can showcase it, right? Because I can do +1 times 2 times 3, right? And I can Control D. Control P, right? Yeah.
All right. Tobias just said project use image segments, and they're not implemented.
All right.
Yeah.
But now we can. What do I do? How can I now?
You can click on the mouse.
This one?
Yeah, and then save and
Oh,
quit.
this is a mouse. Okay.
Yes.
Okay, it looks a little bit like a cat, but it's okay.
Save and quit. You can do save and quit.
Right?
Yeah.
Yes, exactly.
This will do the inverse of loading the image. And
Okay.
now, if you run TruffleSqueak again,
All right.
that should give you the same view that you had before.
Yes, it does, and it's here. Okay, cool. Because that's the snapshotting from images.
Yes, I wonder what would happen if you snapshot call target browser. It would probably just all be gray again.
You mean what do you mean the? Oh yes.
Yeah, all methods would be gray in the beginning,
Right.
and then
Right. Because it's not part of the snapshot. Yeah.
Yes, that won't be part of the snapshot.
Right.
Okay, do we have any
Cool.
other questions in the chat?
Yes, there are questions in the chat. Do you want to explore more, or?
Well, I'd love to be able to persist some of the code that's been generated by the Graal compiler. That would probably keep the number of compilation units smaller too. But,
All right. So Family Pape is asking in between run profile data, please. Okay. What does that mean, Fabio?
I'm guessing Tobias, do you mean what I just described, or can you elaborate some more?
I think it's just when one run stores the profile data, right?
Yes.
About which code is hot and not.
Yes.
Like not even necessary like the compiled code, but just the profile. So kind of sort of like PGO.
Yes. Yes.
Profile for the truffle methods.
It's like Smalltalk images.
Oh,
for
we can do the espresso thing, Fabio. We have.
Oh, do you have espresso installed?
Not yet, but it should be fast, right?
Yeah, close TruffleSqueak.
We have a few espresso team members, I think, on the live video audience.
Yeah, of course.
And so
we can give that a go.
We should certainly give that a go.
Yeah.
Because...
Yeah.
All right. Okay, good.
Okay, so GU install espresso.
Let me just check if I have it. I don't have it. GU install espresso.
Okay, do you have to run something?
No, it's just a rebuild. That's okay. Java minus truffle should be working.
Good.
This version maybe. Oops.
So the very first version of
that's espresso. Yeah, right.
Yeah, the first version of espresso does not support polyglot evaluate. That will hopefully follow soon. But we can interact with espresso through indirection. Oh, you managed to open this twice. Close the window. Yeah.
Okay.
And maybe give us a little bit more space.
I guess I froze it with the exit window.
Yes, you froze it with the exit.
All right, good.
So there's another thing in the GitHub gist that we should maybe share one more time in the chat. So if you type in polyglot primitive get scope,
yes,
this does a top level scope lookup for the given language. So what you do here is basically getting the top scope from espresso. So do a command I for inspect.
Command I, okay.
Yeah, and it feels a bit slower now because the runtime environment needs to warm up.
Right.
So for some reason, the first version of espresso has decided not to expose any members. So we don't see anything, but this is something that we just learned, right? So there's no members, but magically we can still invoke members that we don't see.
I see.
So like if you type in something into the bottom of the workspace, like interop invoke member, you can copy that over from the GitHub gist.
This one
no, put that into the inspector.
Oh, into the inspector. All right.
Yes. because we are sending
get
a
property.
message.
Yes, get
sending a
property.
message.
Yes, get property.
Yes, we're sending a message to this
Right.
object, which is self.
And I do it or debug it or
print
it?
Print it. So, okay, interesting. So what does this say? Member get property. This is a debugger, and resize the debugger so we can see the full error message.
Right.
Is not invocable.
All right. So maybe the version I have is not compatible.
It will likely stay like that though. Okay.
All right.
Yeah. Is there a typo in the method descriptor? Let me see.
Yeah, there is actually. No, this seems odd, right?
Yeah,
why was there a slash there, right?
Weird.
Oops.
What did you do?
Print it?
No. I think this actually belonged there. Let's see. I think we tweeted a screenshot of this. Maybe I can spot the error. So
there is a suggestion in the chat that maybe you need the read member Java-lang system first, no?
Yeah, a suggestion from Eric on TP.
All right. We need to do interop read member self.
What? Okay. Interop.
Yeah, interop read member.
Okay.
And colon self. Member colon system.
System. Okay.
Right. This it should be Java lang system.
Right, but do it to the full Java lang, like this.
Yes. And evaluate the 2 lines and inspect it.
Okay, and I inspect it. Yes. Okay.
Okay. Here we go. So.
Yes. Now I have a get property. That makes sense.
Yes. Now you have a property. Okay, so the red property says it's not readable and it's also not invocable. So there's likely something wrong with the interop implementation.
Right, but there is an out here, right? So system out println. Can we call out println here? Self, just.
Yeah, that's also in the gist. Hang on, let me check.
Self out, yes, self out, and then the memo and hello from Truffle. Yes,
copy that over.
That sounds about right here.
Yes.
All right.
Yeah, so I missed the line in the doc. I'll add that.
All right, and we print this.
Do it or print it.
Yes, okay.
Fine. And now look at your console.
Yes.
There we go.
Okay.
And now you can also copy over the other statement.
All right, let's check out the other statement here, which is this one, right? Yeah, okay.
Yes.
Okay.
And the last thing you can remove because that's a comment. Yeah, you can remove the comment.
We don't need this because, yes, okay.
So print it.
Oops.
Oops. Yeah. Command A, Command P.
Command P.
Yeah.
Foreign string.
Yep. And the content of the string is espresso 64-bit VM.
All right. Okay. Cool.
Yep.
Very cool stuff. Yes. Okay.
Can you click on non-readable members again?
Non-readable members here. Yes.
Yeah.
Okay.
So I wonder what's up with get logger, get property, and get env. These are probably bugs. And
right.
Eventually, either they will be fixed or I will file a bug.
Yes, you should file a bug on GitHub against the Espresso project.
Yeah.
All right, cool. So yeah, that was all of the examples here. Oh yes, we did something before on the demo, which is increase the font size.
We skipped a few.
And yes, if you want to try this at home, this is the gist on GitHub, where we will share the link, and you can check it out. Give it a little bit of time to install everything. We kind of went through it. It worked well, except for one thing, where for no Kokiri we needed to do a trick to move the include files from the inner directory to the outer directory. I think Fabio will add this this little thing here to the gist in case somebody else will run into it. And then you can try out the awesome Smalltalk environment also on your machine.